All right, hi there, AP Bio. Here is the video to talk to you about how to do your Sesame Street activity. If you did not get this handout already, you do want to get one. They should be up front in the former handouts. In addition, there's a whole bunch of other handouts up there that are about DNA replication, transcription, translation, etc. That was just me being proactive last Friday in case schools closed. So if you weren't here on Friday due to a field trip, please collect all those, get a paper clip, hold on to them. We're with anything we get to them this Friday. So to do your Sesame Street activity, this is a single solo person activity or a partner pair or a trio. The most you can have is 3 people on a team because you'll see in just a second here. So you should have this document that has the genotypes and phenotypes of all the characters. On the orange cart should be a colored in version of these characters to show you colors. But they are also described down here in the bottom as well. So your goal is to create a grandchild. One partner pair, assuming you're in a 3-person team, will mate together 2 Sesame Street characters, one male, one female. I am fully in support of same-sex families having children, but biologically we do need to have a male and a female to represent the correct meiosis interactions. So let's say Zoe and Elmo have some children, and then another partner will do Prairie Dawn and Ernie. They will have children, and then that will create the F1 generation. Those original Sesame Street characters need to produce at least one male and one female of different families to then meet and create those grandchildren, which is what the 3rd person of the team could do. So you're going to be showing a 3-generation pedigree, something like this. If your team cannot draw, do not panic. You can kind of trace these guys, or if you don't want to draw at all, that is fine. You just need to, in the pedigree, list what is the genotype of that character and the corresponding phenotype. If you do choose to go ahead and draw, you don't have to tell me a phenotype that I can see. Like if I can see what color they are because you've colored them, great. These are the colors. They are the incomplete dominance inheritance. The eyes being exo on top of the head is dominant, like Elmo here with a big E. Little e would be endo eyes within the face. Nose color, pink, is dominant to orange, and it can be any color of pink. Orange, any color of orange. Tongue, having a tongue is dominant. So Grover's mouth is closed here. He does not have a tongue. Prairie Dawn, when her mouth is open, she does have a tongue. Otherwise, like, that's a tongue, that's a tongue, that's a tongue. Body color, like I said, you have a whole chart right here of all the possibilities. Blood type runs just like human blood type, A, B, or O, or AB, codominant. And then the sex-linked traits are colorblindness, also just like humans. Let's say X with a big B is normal vision. X with a little b would be colorblind vision, so they're either unaffected, colorblind, or carriers. And then the last one, baldness, is also a sex-linked trait. X with a big F is the fuzzy dominant trait. So to be recessive, like Bert here, and be a bald body with just hair on the head, he only has X little f with his Y. So what you're going to include is obviously the pedigree that shows me the genotypes and the phenotypes. If you're drawing them and coloring everything in, the only thing I can't see would be the blood type and the color blindness. Everything else should be included in your drawing. To show your work, please show all your Punnett squares for that familial cross. Everything can be a monohybrid, but 2 traits do have to do a dihybrid. And each mating pair must have a unique set of 2 traits in the dihybrid cross. So one partner can do like crossing eyes and nose as a dihybrid trait. Another one can do, nose and tongue. And another one can do like nose and baldness or tongue and blood type. What I do not recommend in your dihybrid cross together is colorblindness and baldness, because those are both sex-linked traits, and those traits should be linked together, and you can't quite represent that in your dihybrid cross. I'm going to not give you the dice on Monday. Please go ahead and use your random number generator on your calculator. So in your Punnett square, you could random number generate in your calculator integer 1, 2, 3, or 4 for which offspring genotype do you get, or 1 through 16.